Hi. I guess we can begin. Um, Let me just switch the video feed. Okay, rewind the slides. Thanks again for joining me. It's really nice to have you guys back for part 3. So yeah, I'm kind of excited to go. This is actually the first time I've been streaming ever, and it's actually really fun and a little bit addicting. I have to be honest. So it's really fun to do, and I'm really excited to dig into part 3. Incidentally, I apologize for the noise. I'm in Da Nang in Vietnam right now, and there's a lot of construction going on all around. So it's really hard to find a spot that's like, you know, really quiet and stuff, and still has good internet. So there's a bit of construction noise here and there. So I apologize if at one point it gets a little tough to hear. I'll do my best though, and yeah, I've tried to clean up the audio, but I can only do what I can do. All right, so maybe let's dig in by doing a little recap. So in the first session, we kind of bootstrapped the app. We built a HTTP server using Node.js's built-in HTTP module. We wired that up to a public directory where we serve static assets out of. We implemented dynamic routing in the session 2, this last one, a couple weeks ago. So now we have basically dynamic content that's populatable into the individual routes, not just static files. And finally, the routes are templated using handlebars. So we've got all that stuff working now. So we've got kind of the beginnings of an awesome app, a really easy to build app. But of course, we need to do a little more. So today, well, first, maybe I'll dig into a piece of feedback I got from Christian van Omeren. And he basically watched the first 2 streams. And the first one he found, I guess, easier to follow than the second one because the second one kind of ramps up in difficulty, and maybe I covered more stuff than I should have in that one. It was kind of a complex one because, of course, it was routing and also templating. So those 2 things maybe could have been split up. In this one, for example, this stream, we're just going to be focusing on form data and a little bit about using the Chrome debugging tools, or the debugger, essentially, in order to help us get more visibility into our app. But besides that, we're just going to keep it really light this time because, yeah, perhaps I loaded in too much into the last one. So I don't want to overload people or burn people out. So just going to try a little bit slower this time. Okay, so let's dig in. Some of you may be familiar with the debugger already, and you may have seen it in front-end frameworks. It's very common to be used in front-end frameworks. So for example, Ember.js, I know, uses it out of the box. You can use it with React out of the box, pretty much. You can use it with Vue.js out of the box. Basically with anything out of the box. And what it does is a debugger is an attachment to the Chrome developer tools. And the attachment allows you to sort of stick yourself into the app and help you debug better by, for example, giving you breakpoint functionality. So you can stick a debugger statement anywhere in your code. Like, for example, on the screen there, I have on line 4 a debugger statement. So the app will actually pause execution on line 4. So it will pause and debugger window will pop up. And if I was going to run this in browser. Node.js is a little bit more complex, but not much. So in Node.js, ever since I believe version 10, or was it 9 or 8, I can't really recall, but they've had the inspector built into the app. Now this is possible because Node.js under the hood uses the same JavaScript engine as the Chrome web browser. So they both use the engine called V8. And that's made by the Chromium project, aka Google's stewardship of that project. And it runs both in Node.js as part of the server-side element of it, and also, as a browser virtual machine. So in order to trigger this mode, all you have to do is run your script with the -- inspect flag. And let's look at the code here for a second. This is our app. If we look at the package.json, where we define the start script, we are already running nodemon with the inspect flag. So nodemon, remember, is just a way for the app to watch files and restart. And inspect actually gets passed to Node when it runs the command. So you don't actually need to do anything as long as you run npm run start and not just directly node app.js. It will actually run with the debugger enabled. So without further ado, let's get started. A piece of feedback I received was to minimize the windows I had open. So this time around, I'm going to run the terminal from the VS Code editor. So it's at the bottom of the screen. So in case you're wondering what that is, I'm not doing anything crazy. I'm just running npm run start in my project repository directory. In order to run the Chrome developer tools, let me close that out for a second. You need to have Chrome or Chromium installed on your machine. So I have Chromium. And in order to start the debugger up, you need to launch the developer tools. And if you have your Node app running and it's hooked up to the inspector, then you will see this little green hexagon right here. If you click it, out pops another window, and you'll see here that it's outputting stuff from our app into the console here. This is exactly what we want. So all console logs will now end up being patched through into this developer tools instance. Now you may be thinking, what's so great about that? Like, what's the point? And I'll show you. So if we go into the initializer for HTTP that we've already built, we can actually insert a debugger statement somewhere. So the line that you're currently seeing in Chromium, remind us running on port 1234, comes from line 54 here, right? So that's great and all. So let's try using a debugger instance, and I'll just show you how it works. So let's put a debugger right in the create server callback function right here. Okay, so if we run our server, you'll notice that, the server won't load. And it opens up the developer tools. Well, that's because the debugger is here, and by using the debugger, we've created a breakpoint. So now we actually have access to the current state of the application, which is great. So now, for instance, any variable, like for instance, you might know that we have a request variable and a response variable. Well, if you ever want to preview what that is, you can just type in request, and this is the variable itself that you can preview. So like, if you want to see all of the headers, they're there. If you want to see the different details of how the inner workings of the request object work, it's all there. And the advantage over using just console log is you're not going to see this level of detail and interactivity with just console log. So if you just need to know what the value of a variable is and it's a string or a number or something, a console log might be easier and faster. But in the case of something complex like a request object, it's actually great to have this level of detail in some of the stuff. And then of course it also has the map. It's also mapped to the correct files. So you'll notice that, for instance, I know that the debugger statement is being launched, and on line 54, this console log here is being run as well. So it actually does have source maps, and it's hooked up to your Node.js instance. So essentially, think of this as almost it's like running this code in the browser. You have the same level of detail that you can view. So it's actually really great. I would really highly recommend using the debugger more. Like, I'm guilty of this myself as well. I use that console log statement way too much. I console log lots of stuff, and because it's like quick and easy, right? And I'm not just using it in Node.js. Like before that, I did Ruby, so I putsed everything, P-U-T-S, putsed. And before that, I was in PHP, so I echo statement everything. Well, this is it's not a bad thing to do, of course, but sometimes there's just some things you can't debug with a console log. And I'll give you an example here in the slides as to what I'm talking about. So take a look at this object, right? So you have sample data, and it's an array. And inside the array, there's an object with a bunch of stuff in it. and there's another array inside of that object called friends with a bunch of user IDs, right? Well, if you output this as console log would, you end up with the result like this. So you get, you see that the first level is an array, the second level is an object, and you even get some of the properties of that object. But then the third level, you no longer have visibility into because you're console logging it. Yeah, there's a certain limit to what you can output into the console. And the debugger, on the other hand, allows you to view the whole thing. So you'd be able to traverse the entire tree of that variable, just like I am doing right now with the request object. So this is really good for debugging some of the stuff. Like, for instance, headers, you can see them all that are being sent with each request. It's super easy to use, and I would highly recommend you use it whenever you can, whenever it makes sense. So I'll stop talking about the debugger now, and we'll move on to something that we're going to cover anyways. So let's talk about forms. The form method is like the form concept is actually really simple. So as you see here in front of you, the first little snippet here, the form HTML tag. It's been around since the beginning of the internet, essentially. And the form tag has not changed that much. It has an action, a method, and it has certain components on the inside. For example, in this little snippet, there's a text box input, and there's a button that says submit on it. So when the button is hit, the form does that action by navigating to my endpoint, which is the form action, using the method provided. So in simple HTML, it's post or get. So that's the simplest sort of iteration of a form. Now, most forms today on the internet aren't quite like this, and the reason is because they use front-end frameworks. So the little snippet below is the very simplified version of what a front-end framework like React or Vue.js or Angular does. So what it does is essentially attaches an event listener to the submission of a form. And the code here is quite simple, so it would actually work as a piece of JavaScript with the previous snippet. So it selects my form, it adds the event listener on the submit event, and then when that event is triggered, so when someone hits the submit button, I am preventing the browser from doing the default action of the submit event, which is to send someone off to my endpoint with the method post. And so what that front-end framework does is it creates a request using AJAX requests instead. So here on line 4, I'm running a fetch request. This is obviously simplified semi-code. Might not work as intended, but you get the idea. So I'm fetching the endpoint, and I am using the post method, and I'm submitting a form body that I define here. So that's essentially what a front-end framework does. So when you think about it, it's actually not that different from what you could build yourself. And if you, I'm not going to harp about frameworks because that's kind of the whole point of this course, but it's quite simple what it does. You can build this yourself pretty easily. But the complicated part about forms is not so much writing the HTML and then hitting a submit button. The complicated part about forms is parsing it on the back end. And this is notoriously complex because there's a lot of variables in the actual process. So for instance, you have content types. Front-end frameworks tend to use formats like JSON, JavaScript object notation, or XML, for instance. Like the really horrible ones use XML. But so those content types don't work quite the same as the ones that were originally created with this form. So this form right here that you're seeing, the form action method and such, the content type is actually a specific type called form data. And it's just it's slightly different format than JSON. So JSON, as you know, it's an object that's been turned into a string with arrays and objects in it. And the data type of this particular form will just be query strings. So that's a little bit different. The second part is multi-part data. So sometimes a form is so big, or it has the capacity of being so big, that you need to send it in multiple parts. You don't want to overload some, like if you're uploading a video or you're uploading an image or something. Oftentimes you probably don't want to send it all in one go because that's a lot of data to send. And so you send it in what's called multi-part. So what it does is essentially streams chunks and chunks and chunks of data. It breaks it up into little pieces and it streams that data to your server. And that's what a multi-part form is. This is the most common use case of this is file uploads, but there are others. So a multi-part form may or may not contain a file upload, but at the same time, you have to account for both file uploads and multi-part by itself. And the last part is, of course, validation. Well, not quite the last one, but the last one maybe we look at. So validating data, of course, you need to do that on the back end as well as the front end. So validating that form data also needs to happen somewhere in your routes or in your body parser. And last one, it's not quite on the list, but of course you also have to worry about security. So there's a lot of different remote code execution attacks or XSS, cross-site scripting, that you need to worry about when you're writing your own parser. We won't get into that this class, but there will be a supplementary lesson on security. There's a few things we need to actually take care of. But yeah, we'll look at security more in depth there. But in this particular session, we're just going to look at creating a very naive implementation of a form parser. So yeah, so you get the idea. This is a lot of different stuff to worry about. There's a lot of different branches this could go. So this is a very naive version of a body parser. And what do I mean when I say naive? Naive is a naive person is someone that is not very knowledgeable. So this particular body parser accounts for only the best possible possibilities. So it's not going to save you in the case of something going wrong because it assumes nothing will go wrong. That's what naive means, I guess, in terms of software development. You see here, it's not that complicated per se, but we're using the default type of content type, so that's query string, and we are assuming that the input is actually a string. So, for instance, when you're uploading files, you might have a binary file type. There's also other file types besides just query string data that you can send. For example, JSON. So this query parser will work very simply, but it needs a lot more love and a lot more attention in order for it to be actually viable production code. But at the moment, it will suffice for what we're trying to do. What we want to do is to be able to submit the form in the previous slide here, for instance, and we want it to be processed by our server, or at least to picked up by our server. So the data that a default form submission sends is, like I already said, query string. Query strings are just the same as when you type into the browser and you put a question mark and then you fill in a bunch of key values. And that's essentially the data type that a form submits by default. So it serializes it into key equals value, and then ampersand to separate the data points. So this form parser, like I said, is very naive, so let's use it with care. But speaking of that, let's dig right into this. Let's remove this debugger statement because it's going to be doing some crazy things with our app. Let's first of all, yeah, we're good. So let's create a file in the lib directory called body parser.js, and we'll paste in our naive implementation of a body parser. And we're going to export the function. And what it does is it takes a request parameter and it returns a promise. So here it starts essentially a string object, a blank string. And a request is in JavaScript or in Node.js is a stream. Streams are a really complex thing to explain. So maybe like most of it's out of scope, but I will try to keep it as simple as possible. A stream is essentially a chunked, like you're trying to take something of a whole and you're sending pieces of it along as time goes on. So here, a stream essentially has several standard events. It has an end event, so that's when the stream ends. It has an error event, that's when something goes wrong as part of the stream. And it has a data event, and the data event happens every time a chunk is received, right? So this naive parser takes the request object and attaches these ons, and an on is essentially an event listener. So when the data event happens, this callback function is run. When the error event happens, we launch the reject argument of the promise. And when the end event happens, we run our parse form data method that we imported from query string, and we resolve the promise with the data from the parsing of query strings. And of course, the whole thing is being exported. So now we need to plug this into our app. Well, first of all, let's go into our templates. We're going to maybe add this into the root template. And let's create ourselves a form. So first of all, we're going to create a new route. And that's going to be routes new reminder.js. New reminder.js. And we can just copy and paste this, and I will go through it in 1 second. All right, so this is kind of the format that we're using for, body parser. There we go. And we need to create a corresponding template file. I'll do that first because it's throwing errors in my console if I don't. So copy that into there. All right, so we've created 2 new files, new reminder and new reminder template. The template itself is pretty straightforward. It's just a bunch of simple HTML tags, and it outputs handlebars that we predefine here. Now, you see we are importing also our get request body. That reminds me the body parser, apologies, it needs to be modified slightly. We need to put it in brackets because we're deconstructing it here as well. All right, so get request body. And we are running it inside of this data function, which takes a request argument. And we're just passing that to our get request body parser. And then we're saving it to a variable called form data, and we're returning this. And the intention, of course, is that there will be 2 fields as part of the form data. There's an email field, and there's a message field. So handlebars will be able to render the response based on the data submitted in the form. So that's our intention. Here is the URL we're going to be submitting the form to, /new. The template file, like I said, is in the template directory called new_reminder, and the method will be a post request. And the last thing we need to do is to stick the form into our root template. And that's where I'm going to, this thing is going to live for now. All right. So if we, let's see, refresh our app. Let me try restarting. There's our form. So it's ugly, yes, but it is an email field and it is a message field with a submit button. This is, again, nothing crazy. It's just a simple form with the action submitting to the new endpoint, and that corresponds, of course, to our new reminder route. So it's submitting to here, essentially. The method is post, like I said. And then we have an input type with the name and ID of email, and we have a text area with the name and ID of a message, and obviously a submit button. So this needs a little bit more in order to work. and that is, you might have guessed, maybe not, what is this exports.data thing? We haven't used this before, right? So in our root template, we don't have it because it's just a normal view. Well, we are going to invent a lifecycle method, aka a hook. So if you've used, for example, React or Vue.js, you are familiar with the components lifecycle. And if you haven't, I'll explain it briefly. As something happens, as a bunch of processing happens in the context of a request, the headers are received, a bunch of processing happens, we verify who the user is, for example, and then we create the response. So there's a lot of steps there that we can actually fill in the meantime. There will be certain times when, for instance, user data has been submitted, and we want to do something with that data before we render the template. So there's a few steps that we should look at beforehand. If we had a login form, it might be nice in order to verify who the user is before we move any further in rendering the template. Because, for example, the template will need to know who the user is if it's going to display, a logout button and a "Hello, Mike" message. So to do that, we are going to create a lifecycle method, a hook, so to speak. And that hook is what you see on line 12 to 15 in my little example snippet here of the serve route function that lives in our responder. So if you remember from last session, we created this beautiful, beautiful file, and in it we served static files in one function, and in the other we processed routes. Now, again, the difference between the two, if you are a little bit lost, static files are things like images or CSS style sheets and so forth, and routes are dynamic content. So they require a little bit of processing, and they don't have a file extension. That's how we're figuring out what they are. So here we're going to attach our lifecycle method. So the first thing we should do is we should create a context. A context is something that we're going to pass into handlebars, as you see. And if the data method is set on a given route, then we want to populate the route context with whatever that function returns. So to make this a little more clear, this function is going to be run at this spot before the page is rendered, and the output of form data then will become the context of that route. So here, we're creating a route context object, and in the case of our new reminder, we have a .data function. So we're going to await for route.data to resolve by passing it the request as well. And we are going to then pass it into the handlebars instance in order for it to render, so that all of the things that we set in route context will be available in the handlebars template. Right? I hope that's somewhat clear. We can go back to it and look at it when it's actually working, and it'll probably make a little more sense. So let's go ahead and do that. So like I said, we're going to first create the route context. And we do that here, right after we render the base page. So this is essentially just a plain object. Then on the next line, we will check to see if a data hook exists. And if so, we are going to populate route context or change its value to be the value of route.data. And we pass in the request. You might be asking why. Well, because we want that to be available in the .data function, because this is where we figure out what to do with it. And in this case, we're going to parse the request body. So yeah, we need to do some stuff with there. So that's why we pass in the request. We don't need a response because the response is handled elsewhere. We just want the request because that's where all of the headers are, that's where the form data will be, and so forth. So the next step is going to be, instead of just passing in the global context of our app, we are going to be passing in this little statement that takes the global context that we pass in to our serve route and attaches it with route context that we obviously populate from the route data function. So when we save this, this is actually everything we need to get going, I think. And let's test it out. So here we have an error of some sort. Route is not defined. Yep, that's possible. Oh yeah, because we need to do route key. There we go. So there, that should work. Let's start again. Okay. So now, this is the moment of truth. Test at test.com. Test, blah, 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 blah. And if I hit submit, hopefully everything will work. And voila, look at this. My email data is being populated, and my message is being populated as well. Simple HTML, as you see here. And that's done through the handlebars, and also through our data hook. This is actually kind of all I wanted to do today. So let me see if there's anything in the chat or anything we should cover. But basically, this is form processing at its most basic. So there's a few things we need to worry about, like security, for instance. That's a valid concern. And like I said, we'll cover that in a different session. But another thing is, of course, multiple types of content. So a lot of JavaScript frameworks, for instance, use JSON as their content type. So at one point, if you're building something that's going to hook into a front-end app, or for whatever reason you want to also support JSON, you also need to build into the form body parser the capability to parse JSON. And on that note, I'm going to update you guys on something. So I talked about last stream that I'm going to be releasing some of these modules. Well, the first module is going to be the body parser. So I'm going to use the exact same syntax as you're seeing in your app right now. And I'm going to write a full implementation of this, including multi-part data, including file uploads, including JSON, and also open to other content type implementation. And it's going to be super simple, and you're going to be able to follow it, and you're going to be able to read through it and understand what's happening. But it's all built on this very specifically simple and naive implementation. This one, of course, uses some fancy stuff like buffers. And in the case of binary data, we need to worry about it a little bit more. But in this case, we know that the buffer is going to be a string. So we just convert that buffer to a string. But in the case of an image, for instance, if you're uploading an image, well, if you've ever accidentally saved a JPEG file as plain text, you will, of course, know that it corrupts the image and you can't get the image back as a result. So we can't do that in our get request body function either. But that's essentially, yeah, all I wanted to cover today. So we're going to get deeper into request bodies a little bit later. And for the moment, as promised, I'm going to release this module in a few days when I'm done writing it. So let's see if I can give you a short preview of it. Let me open that folder where I have it. So I've started writing it. I'll give you a quick sneak peek into that library. So you see here, it gets a lot more complex. So to give you just a quick rundown of what's happening, of course, in the case of attachments, we only want to allow certain attachment types. So that will be a factor as well. We're going to support 3 different formats out of the box. So there'll be JSON, the regular form format, and multipart. And a multipart may or may not have a file attached to it, so we need to handle files. And then, of course, the output should always be a simple JavaScript object with all of the keys that the form submits. So this is just like a rough preview of the module, and I will go through it next session. a little more in depth, because then it'll be fully written and you guys can preview it all you want. But this is not finished yet, and I'm just showing you this because it gets a lot more complex if you just go out from the naive implementation. All right, so I would love to hear from you, anything that you want to say, if you have anything to say on the session. Other than that, let's see, do we have anything else to cover in the notes? No? Let's take a moment and be happy that we created a form body parser, which is one of the more irritating tasks to do. And yeah, that kind of wraps things up. So the next stream, we're going to be taking that data and putting it into a database. And this is where we have to start worrying about security more, because we can't expose our user data, and we can't also save potentially hazardous data into our database. So anyways, I would love to hear your feedback, so hit me up on Twitter or on Telegram. The Telegram channel is frameworkless for this program. The code for today is, as always, available on GitHub, so you can follow the link or go to the repository yourself. And there's a running example of today's code on part3.remind.ist. Also, I invite you to follow the Twitter account for this particular app. It's called Remindist, so feel free to follow it. Yeah, I just launched it yesterday, so you can go ahead and follow it. And the app is, of course, running currently, so you can preview it in its semi-final form here. Anyways, thanks for joining, and yeah, I'll see you in a couple weeks. So the next stream will be 2 weeks from now. Let me check the calendar and see when that will be. So that will be on the 23rd of July. So I'll see you on the 23rd of July at 7 o'clock UTC/GMT, 1400 Indochina time, and I think it's super early in the morning or in the middle of the night for US viewers. Anyways, yeah, all the best, and thanks for joining. Bye.